So if you remember me saying, all right, dial in. If you remember me saying we only have 3 chapters to cover, and that's because they are dense. That's why we only have 3. I've broken it into a mid-chapter and an end-of-chapter. So the mid-chapter 6 is going to cover, if I'm not mistaken, 6, 1, 2, 3. I think it's 6, 1, 2, 3. And then we'll have a mid-chapter 6 exam when we finish 6, 1, 2, 3, and then have a review. 6.1 should be the easiest lesson of all because it builds on what we practiced last week with special right triangles. Look at this slide right here. This is a refresh of some vocab. An acute angle is an angle that is less than 90. Technically, it's an angle that measures between 0 and 90. We've always said less than 90. And then there's some Greek letters of the alphabet that you need to be familiar with that you're going to see. One of them's from geometry, and that would be theta. You've seen theta in geometry. The others you may not have seen as often, but you will see them in this class. You got alpha, beta, gamma, and phi. If you've ever been on a college campus, especially the larger universities that have sorority and fraternity chapters, you may have passed buildings and seen these logos on the top of the buildings. If you've ever been to Neyland Stadium, you would pass them on Neyland Drive. Fraternity row, sorority row. Anyways, these are the same Greek letters that are used for fraternities and sororities.
Do you know what it is? Like, why do they associate everything with like this? Is there a reason?
I'm sure there's some historical reason, but I don't know the answer. And now I'm curious, so I'll have to look it up. I'll have to look it up. I did learn the answer to Trent Baldwin's question from the class that you were in last year, the difference between a bank and a credit union.
Oh,
I finally learned the answer to that. A bank has shareholders, like they make profit, and credit union does not. It's like the people own it. Credit union? Yeah, I think now that I know the difference, like I'm leaning more towards credit unions because banks. That's why banks can go under because they have investments. Yeah. And I'm like, you're not going under with my money. What little's in there? Leave it alone. Okay, go to this slide. This should look familiar. You've got a picture of a standard right triangle. I've labeled one of the angles, acute angles, as theta. Let's draw the arc to emphasize your attention to it. Because theta is in that corner, I've labeled opposite adjacent based on theta. Hypotenuse doesn't change. It's always because of the location of the right angle, right? And it helps to draw that arrow. Then you will see the 6 trig functions laid out, no abbreviations on the definitions. You've got sine, cosine, tangent, and then you have their reciprocal functions, cosecant, secant, cotangent. Let's label them right here. This is cosecant, secant, and tangent. Cotangent, sorry. Left the co part off. We talked about how you should never mix up cotangent. It's the reciprocal of tangent. But then we said, how are you going to distinguish cosecant and secant? And I told you the silly way that I remember is that the first letter is the opposite of its reciprocal function. So cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. That's how I remember. Sine, cosine, tangent. If this is helpful, writing SOHCAHTOA like this might be helpful when you're doing some of these problems. Shows you the formulas. It shows you the stacked fractions. Nothing wrong with writing that down and using it. Even though I know the formulas by heart, I still write that down. Like, I don't know, it's like muscle memory. I still write it down. Okay, so let's just practice. Very simple, dipping your toe in the shallow end. We are just writing the trig ratio, which means you're getting the fraction based on the function it's telling you and the angle it's telling you. In the right triangle shown below, find the 6 trig values from theta and from alpha. So you do have to be careful. So all 6 of these are theta, all 6 of these are alpha. Guys, if you find the sine, cosine, tangent, then the reciprocal functions is just the flipped fraction, right? So you should only have to think for 3 of them. And then the other 3, hopefully you got those right, and then you just flip them. So let's look at A. We are focusing our attention from theta, so be careful. I'll do 1 arc. So from theta, doesn't really matter where theta is. What's 13? 13 is the hypotenuse, so it's safe to put an H there because that does not change. What's the trig ratio, aka fraction, for sine theta? Opposite over hypotenuse, so that would be what? 12 over 13. When I say trig ratio, which I need you to learn that phrase because you see right here it says 6 trig function values or trig ratio, they're saying find the fraction. All right, cosine of theta. Adjacent over hypotenuse, so what would it be? 5 over 13. Tangent theta. Opposite over adjacent. 12 over 5. If you can get those 3, and of course I would double check them. I have seen people mess up because they just went through it too fast. If you can get those 3, when you come over here, it is simply the reciprocals. Now make sure you line them up. You're going to have to write these on your own, okay? You'll have to write sine, cosine, tangent, and then you'll have to know, okay, sine, opposite letter, so cosecant, cosine, opposite letter, secant, and then of course cotangent. Like you would generate this setup on your own. So cosecant would be 13 over 12, secant would be 13 over 5, cotangent would be 5 over 12. Repeat with alpha. In case anyone checks in, because I think some of you might, the PBIS field trip for tomorrow has been postponed. So it is not tomorrow. So heads up. Don't know the date, but it's not tomorrow. So this time we're focusing attention from alpha. I'm going to do 2 arcs to distinguish a different point of view. What'd you get for sine alpha? Okay, cosine and tangent. And then over here, all I need to do is flip them, right? Okay, I need to show you something leveled up, I guess you could say. Come down here to this space, and we'll change colors. want you to write, let's work with cosecant theta. We need to start practicing recognizing, when you need to write the formula as opposed to just jumping in with the numbers. So here's what I mean by that. If I said find cosecant theta, you would have this list of 6 trig functions, and you would know that it is the opposite of sine, right? Okay, what's another way to write the reciprocal of sine? Look at this. 1 over sine theta. One over sine theta. Another way to write the reciprocal of a function is to do 1 over the function it's coming from. Okay? Cosecant comes from flipping sine. So one way to write that is 1 over sine. Okay? What is sine theta in that picture? What's the fraction for sine theta?
12 over 13.
12 over 13. So watch how I fill this in. Now, that's my big fraction bar. I don't want to write 12 over 13 with the same fraction bar length, because then I'm going to get confused what's actually in the top, what's in the bottom. So I make my bars completely, dramatically different in size. I got 1 over 12 over 13. You see how I did that? That's a fraction within a fraction. You should remember keep, change, flip. So you keep the 1, you change the big fraction bar to multiplication, and you flip the fraction in the bottom. And of course, anything times 1 is itself. So what we just did at the bottom of this screen was the long drawn out process of simply recognizing the relationship here and flipping the fraction. Do you have to do this every time? No, you don't have to do this every time, but this is coming down the pipes, this right here. That's coming down the pipes, okay? Probably chapter 7, if I remember correctly, where you're going to take the reciprocal function and you're going to rewrite it as 1 over the original trig function that it comes from, okay? So, preview of what's to come. Go to this slide. Here, I've given you that 1 over those original trig function formulas. You don't have to memorize them necessarily, because we already talked about, sine, the reciprocal is cosecant, and you should just be able to write the 1 over. If this is foreign to you, then maybe highlight it, circle it, draw your attention to it. All right, look at example 2. Same exact thing we just did. The difference is they are not giving you the right triangle with all the sides labeled. The difference is they're giving you a couple of trig function ratios to start with. They're asking you to find the others. 2 ways to do this. 1, you could draw a picture. You could put the, in this case, phi angle wherever you want in the picture, and then you could fill in the sides. Or, as you're going to notice that I like to do, I like to label, don't write big here, it does get crowded. I like to label, okay, they're giving me sine equals 4/5. They're giving me cosine equals 3/5, and they're giving me tangent equals 4/3. I like to stack them in order, sine, cosine, tangent, because then I'm a pattern person, routine. Sine, cosine, tangent, come over here, and I just do what with them? I just flip the fraction. But I need to remember which one goes to which. Sine starts with an S, so its reciprocal starts with a C. flip it if you want, or you could come back and flip it later. But sine's 4/5, so the reciprocal would be 5/4. I don't even have to draw the picture. Cosine is 3/5. Cosine starts with a C, so its reciprocal starts with an S. And it's going to be 5/3. Then, of course, tangent you shouldn't mix up. And it's 4/3, so the reciprocal is 3/4. So the difference there was no picture, but they still gave you trig functions to start with. And you didn't have to draw a picture because they gave you all three originals, sine, cosine, tangent. They asked for the remaining trig ratios. All right? Same thing here, just ugly ratios. Try it. Same thing, ugly numbers. You do have to rationalize. Remember we talked about like get used to these radicals. It is a major part of pre-calc. But it is the square root of 21, which means nothing's going to break down. So it actually ends up being short and ugly. Like Alabama's football season next year. I'm just teasing. I did hear that their mascot entered the transfer portal, though. I'm just teasing. That's it. I'm done.
4 and 5-star they've ever had.
Not Jalen Milrow. He's staying.
Is he staying?
Yeah.
Good for him. I'm actually completely appalled by the whole transfer portal.
Hopefully him and Caleb Down used to play catch at practice because they can play catch next year too when he's playing for Georgia.
I do think part of Saban's decision to retire is threefold. One, his wife. I read she's got Alzheimer's, maybe?
I don't know.
I think she's got some type of health condition that is debilitating. And then two, I mean, how can you top what he's done?
You can't.
You can't. And three, no, we got 10 more minutes. Three, the NIL, the transfer portal, like I think he's like, you know what? Over it. I don't think he's a Hollywood coach.
Kirby's coming for his records.
I think there's a reason he left pro.
I always forget that he chose the Jets.
Yeah, for how long though? It wasn't long.
I think it was like 3 seasons, maybe.
It wasn't long at all. So all I'm doing is writing what they gave me because I'm systematic and patterned. I have to have it written out. I can't just run with it in the directions. Of course, please be careful if you do adopt this technique. Make sure you write it down correctly. Which I would honor it. I'd have to check it. You'd have to have it on your paper, but make sure you are copying it down correctly. Okay, so I have the 3 original, and it simply asks me to find the 3 reciprocal. I'm just going to come up here. Okay, that starts with an S, so I'm going to start with a C. I've seen people mess that up too. Ben said, that's it, I'm done. All right, that starts with a C. This one's going to start with an S. And then can't mess the bottom one up. All right, reciprocal. So this would be 5 over square root 21. This is a problem. Can't have a radical in the bottom. So I'm going to multiply by root 21 over root 21. And because that number is ugly, it works out nice that it's done. It is ugly. Get used to these ugly fractions with radicals. That is a very common format for pre-calc. All right, this one's pretty. Done with that one, thank goodness. Flip this one. Once again, can't have that. Yeah, did I mess up?
Yeah, it's 2. It's under 5. The square root of 21.
Hold on, let me find it.
You have number 2 in the, as a 5.
Tangent.
Denominator.
What did I just say? Copy it down correctly. All right, so I'm gonna do it as a teaching moment. If you
do it on
this on the
purpose?
test, you do this on the test, right? Because I've seen it. If you do that on the test, I would come over here and check your work and your simplification process, and I would give you full credit because you did it right. My math lab would mark it wrong. I'd have to go in and be like, why did they get it wrong? And of course, I would notice that you had a 5 here instead of a 2, and I'd be able to fix it. Let me fix mine. This is over 2.
Yeah, good
Yes. I heard you say something. And now I won't be. All right. One more, and then
One more slide?
Yeah.
Okay.
one more. Go to example 4. You already put it up? No, you didn't.
Sorry.
Go to this one.
I put the massage.
We don't have that.
Facts.
Yeah, we don't.
Y'all so cute.
No, like,
Water triangle, is it drawn?
no, we actually don't have that.
Oh yeah,
Yeah, we do.
There we
mine's not drawn either. So look at the notes.
You just lied to
It
us.
says no, I didn't.
Yeah, you did.
No,
Yeah.
the timing was
Also
off.
cute.
If sine of beta is 6/7 and beta is an acute angle, find the other 5 trig
I'm
values of beta.
assuming we need to make a triangle.
Same exact question, leveled up by not giving you all 3 original trig ratios. They're giving you 1, which means in this case you do need to draw the picture. And then you need to find the missing side that you don't know, and then you can write your 6 trig functions.
That's so much work.
Your picture may be different than your neighbor's, but there's only 2 right answer pictures. It depends on where you put beta, okay? You can draw your triangle.
Isn't it like a 5, 6, 7?
No, there's not a 5, 6,
There's
7.
not? Oh. It's a 3, 4, 5.
It's 3, 4, 5 triangle that there is, yeah. When you put your right angle, obviously that's going to go in the L shape. Where you put beta varies. You only have 2 choices. It can either go here or it can go here. But it can't be in both, and it can't be on the right angle. So there's only 1 of 2 choices. Now, depending on which one of these you draw, changes where your numbers go for the legs. So when you look at your neighbor, and if y'all have different pictures, don't be like, yours is wrong. You both have the right answer.
Chloe, yours is wrong.
How do you know where to put the numbers? This is how, y'all. Look at this. For the formula, they're telling you, hey, sine of beta is 6/7. What's the formula for sine? Opposite over hypotenuse. They have just secretly told you the opposite is 6, the hypotenuse is 7. You've got to find the third side using the
Pythagorean theorem.
Yep.
A squared plus b squared equals c squared.
So I'm going to draw my triangle like this.
Can you draw it, please? It makes me feel better. I'll learn better.
I did, I drew it. So I drew my triangle, I placed beta right here. I don't like that. I placed beta, and then I labeled my hypotenuse is 7, and then my opposite of beta is 6.
Oh, that's not even.
I've got to find my missing side. So I'm going to do the Pythagorean theorem. I'm going to do a squared plus 6 squared equals 7
There's a
squared.
big door. I'm good. I'm just checking every day.
Can you write me on that keyboard? Do I have to like say something to her?
So we've
You can
got
tell her that you're leaving.
36,
She'll look for attendance. She doesn't check.
49.
She looks around.
We're going to subtract the 36.
13. Square root.
So A is the square root of 13.
Yeah.
So I'm going to come over here and label this as square root of 13. Now, what did the directions say?
Find the other 5 trigonometric function values.
Okay, so here's where you need to keep in mind. You're going to see me do this every time, and you might want to adopt the same habit. I'm going to label sine, cosine, tangent, reciprocal, reciprocal, reciprocal. Like, in my mind, I go in and I do my 3 original, my 3 reciprocal. I even copy the one that they already gave me. It's already there. But I copy it so then I can find its reciprocal. Okay? What is it? It's all beta. So we got sine beta, cosine beta, tangent beta, reciprocals, cosecant beta, and then you're going to look at the directions and use the one they already gave you. They gave me sine, 6/7. So cosecant would be 7/6.
Any student who attends afternoon classes at the Career Academy should now be released.
Let's put your mission on and we're done. That's already.
Bus is here. Again, any afternoon student for Career
Cosine would be
classes,
root
please report
13
immediately
over
to the
7. Reciprocal would be 7 over root 13. Can't leave it like that.
7 to the root 13.
There you go. You're going to notice a pattern. Especially when the numbers are ugly, you should notice that when you rationalize, there's that pattern when the numbers are ugly. And that is y'all. But I got to finish this. It's going to bother me. Opposite over adjacent. Hey, let me say one thing real quick. When I go over here to write the reciprocal for cotan, do I want to flip this? No. That's why it is helpful to put that initial fraction, because then the reciprocal ends up not needing to be rationalized. So grab your paper.
I didn't do that.
Oh yeah. Y'all can give it to me tomorrow if you need to pack up and go home. I would another form. They are going to give you another form. I would honestly hold on to that because I don't see them rejecting that form. I think they're just going to give you another form so parents know legally what day you would be legal.
Qualifying issue?
I would hold on to it. They haven't said that.
Holy crap.